Hi guys. All right, we're going to move on a little bit further in our study of polygons. Remember, polygons are simple closed figures that are made of line segments. And we talked about some of the different ones yesterday. We made a list, remember, because they are identified by the number of sides they have. All right, we're going to move on today and we're going to look at a particular type, triangles. Now, triangles are actually that they have the fewest possible number of sides. If you think about it, you have two sides, you can't, it's not a closed figure, right? So you have three sides. Now, what we need to know about triangles are the ways they are identified, and they are identified either by their angles or by their sides. We're going to look at the sides first. So here's the first one we're going to look at. All right, now do you remember we talked yesterday about how we use slashes to designate sizes. So in this particular triangle, it would have to look like this. Now, do you see how there's a different number of slashes for each side? All right, what that tells us is, do you remember? Right, none of the sides are the same. So this kind of a triangle is what's known as a scalene triangle. And we're going to write down, and yes, you get to write this in your notes. No two sides are the same. All right, so that's a scalene triangle. All right, next one we're going to look at is isosceles. Now, wait till I slash it. Okay, so what can you tell by the ways I slashed it? And yeah, I know my drawing may not be perfect, but what can you tell from that? All right, you can tell that these two sides are the same length, right? This one is not. So if you have a triangle in which two sides are the same length, it's isosceles. And no, I have no idea where they come up with these names. Sorry, I was checking the spelling on that one. Okay, so two sides are the same. Okay, so we got scalene, none of the sides are the same. Isosceles, two are the same. So can you figure out what's going to come next? Right, everybody's the same. Now, I'm going to do the best I can on this, and you do the same thing, because I realize it'll be a little hard to just get it right by eyeballing it, but that's what we're going to try. And we're just going to pretend that all those sides are the same, although actually I'm pretty proud of that one. I think that one's pretty good. All right, if I slash it, all the sides are exactly the same. So this is called an equilateral triangle, because all the sides are the same length. Now, let me ask you something. Okay, take a look at it. If all my sides are the same, how do you think the angles compare? Okay, yeah, the angles are going to be exactly the same as well. And so this could also be called an equiangular triangle as well. All righty. Now, these, though, what we're mostly looking at here are the sides, all right? Scalene, none of them are the same. Isosceles, two are the same. Equilateral, all of them are the same. Now we're going to look at the angles. So our first one, try to make this the right way. And again, don't kill yourself. Don't worry about it if it's not perfect. We just want something we can use as an example. All right, remember, we're looking at angles. All right, so I would say, let's say that this one, and I'm not going to measure it, but let's say this guy is 40 degrees. Okay, and then we'll say this guy is 60 degrees. And then this guy is 80 degrees. All right, so are any of my angles the same? No, they're not. So this is what's called an acute triangle. Notice, okay, notice that all these angles are acute angles. Okay, go back. Remember, what's an acute angle? Right, it's less than 90 degrees, and that's what all of these guys are. Now, you also need to notice something else, and this is true about all triangles. What do the measures of all those angles add up to? 40, 60, 80. Okay, it adds up to 180 degrees. And every triangle, no matter what kind, the angles will always add up to 180 degrees. But let me finish my definition. A acute triangle has 3 acute angles. There we go. Okay, let's look at the next one. You should always use a ruler or a protractor or at least something with a straight edge when you're drawing figures. Okay, now what am I going to do here? Okay, make my little square there. All right, so this is, what kind of an angle is it right here? Remember what it is when we make that little square in the corner? Okay, it's a right triangle because it has one right angle. So I'm going to put 1 right angle. Now I'm going to test you and see if you remember what we talked about before. This guy has to be how many degrees? Right, because it's a right angle, so it has to be 90 degrees. Okay, now let's say that this guy happens to be a right triangle, but it's also isosceles. So let's pretend that those two sides are exactly the same. That means that these angles are going to be the same too. Go back to what did we say? All the angles in a triangle the measurements have to add up to 180 degrees. So over here, if this guy's 90, what do these two have to add up to? Yeah, they're going to have to add up to another 90. And if I tell you that they're the same size, what do they have to be? Can anybody figure that out? They would have to be 45 on each. Okay, it's okay if you didn't figure that out, not a biggie. All right, last kind of triangle for today. Yay! The crowd goes wild. And I hope I did a decent job on that because I'm not sure. Here, I'm going to redo this one. So hopefully you're not trying to follow me too closely because I don't like what I did there. Okay. Oh, there, much better. Much better. All right. All right, so for this guy, here's what I was going for. See this big space right here. All right, if we go here as our base ray, a right angle would be like this, right? If we were going to use that as our base ray, right angle will come out here. So that tells me that this angle is what kind of angle? Greater, which means it's what? Do you remember? Obtuse. So therefore, this is what we call an obtuse triangle in which one angle is greater than 90 degrees. Okay? Now, you don't have to draw what I'm drawing, but I'm going to do some little tests and see if you guys can tell what I'm drawing. But you don't have to draw these unless you want to. You know, if this helps you understand, then go for it. Okay. Okay. See if you can figure out what kind of triangle this is, and I'll give you a hint. There's actually 2 of these terms that would correctly label this particular one. So take a look at it. All right, you figured it out? Okay, because of my slashes, none of the sides are the same length, right? So therefore it has to be a scalene. And I thought this one was a little bit trickier. Look at how big this angle is right here. That would be the right angle, right? So it's way bigger than that. So it's also obtuse. Did you get that? Let's try another one. Again, you don't have to draw this unless it helps you. We're going to use this for practice. Okay, take a look at it, see what you think. Again, it's actually going to be 2 of these terms up here. We'll label it correctly. Okay, let's see how you did. And remember, if I go too fast, you just pause it, figure it out, and then start it up again. See how it has that little box there? So it's a right angle, right? So it's a right triangle. And now if we look at the sides, two of the sides are the same. Do you remember? If they're two of the sides are the same, what do we call that? Isosceles. So this is a right isosceles. Okay. Next one. All right, let me label this guy. Okay, and again, two of these up there are going to label this guy. What do you say? Oops, you can't see him real well, can you? There you go. That's a better version of him. Okay, what do you think? All right, all three sides are the same, so it's going to be equilateral. Now, some of you might have told me it was equiangular, and it is that as well. It is equiangular, but it's also one of the ones that has to do with the angles. Remember, equilateral has to do with sides. There's another one that has to do with the angles. All right, it would be acute. So it's an equilateral, and it's acute. All right, now, let's see if you can use what we've talked about with the angles of a triangle. Do you remember that? We said that they have to add up to what? Right, 180. So I'm drawing a really weird guy here. I kind of like him. He's kind of cool. Let me close him off there. All right. Now, I'm going to tell you this angle. And of course, I'm totally making this up. I have no idea what he really is. I'm going to say that this guy is 130 degrees. Okay? And I'm going to say that this guy is 15. All right. If this guy's 130 and this guy's 15, tell you what, let's go ahead and label these. That'll make it easier. X, Y, Z. All right. So if my Y angle is 130 degrees and my Z angle is 15 degrees, remember they have to add up to what? 180. What is my X angle going to be? Take a minute, see if you can figure it out. All right. It's going to have to add up to 35 degrees. Okay, let's try another one just to make sure you've got it. And again, I'm just making these triangles up. I don't know why I can't seem to meet at my points there, and I don't know why that is. All right, let's say that guy's 60 and this guy's 70. Okay, and again, I'm just making this up. I doubt seriously that they are actually 70 and 60, but let's say they are. Okay, if this guy's 60 and this guy's 70, what is this guy going to have to be? Take a minute, figure it out. Okay, if 70 and 60, you put them together, that makes 130, right? And you have to get up to what? 180. So this guy is going to have to be 50 degrees. And by the way, that would make this triangle a what? It would be acute because all the angles are acute, right? All right, for homework, here's what I want you doing. I want you to be doing, let's see, 8 through 16. This is on page 506, and 40 to 41 on page 507. That's not too bad. Now, before we go, let's go over homework from yesterday. And I actually meant to do this first in the video, totally forgot. Sorry about that. Find your homework, and we're going to go over it. This is from yesterday. This isn't today's homework. This is for you to do today. But yesterday's homework, I'm going to go over the answers. And if you don't, I will try to explain them. But if you don't understand them, remember, you can email me or text me. All right. So A said number 1 was what figures are simple? Okay. A, B, and C. D isn't. Why? Because remember, if the line crosses itself, it's like a tangle in yarn, and it's complicated, it's not simple. Then which one of them are closed? Only C would be closed, because they would start and stop in the same place. Now let's look at number 3. Which of the figures are polygons, and then which ones are convex? All right. Was A a polygon? Remember, a polygon has to be made of line segments. Yes, it is. How about B? B was. How about C? Do you see how they put that little curvy thing in there? That's not a line segment. It counts as a curve because we've talked about what curves are, but it's not a line segment, so it doesn't count as a polygon. How about D? Yes, D is. Now, it says which one of them are convex. In other words, which one of them has all acute angles? Okay, well, let's look. All right, I'm sorry, not acute. Less than 180 degrees. My fault. Less than 180 degrees. So let's see. How about A? Yep. How about B? Well, look here. And I don't know how well you can see my book. But remember that when we're checking this, we're checking the interior angles, the angles on the inside. If you look at B, look at this angle, because it has to be on the inside. See how it goes all the way around? That practically makes a whole circle. That means it's a really big angle. Okay, it is nowhere near less than 180, so that one can't work. B can't work because it's not a polygon. All right, and then for D, again, look, on the inside, we have some really big angles, so no. So the only one that actually fits the convex would be A. Now, which of the polygons are regular? Remember, a regular polygon has to have the same side, the sides have to be the same length, and the angles have to be the same. So let's look. How about A? 2 sides are long, 1 is short. In fact, we just talked today about what kind of a triangle would that be? Isosceles. How about B? Yep, square is a perfect example. C? 2 sides are long, 2 are short. How about D? Yeah, the sides are the same, and that means the angles are the same. All right, number 5, a pentagon has, whoops, you can't see my butt, can you? Okay, a pentagon has 5 sides and 5 vertices. Vertices are just vertexes, and a polygon is going to have exactly the same number of sides as it has vertices. Number 6, a polygon must have at least 3 sides. And then the sum of the measures of the angles in any triangle is 180 degrees. And I'm sorry because we didn't go over that. We went over that today, so don't feel bad if you didn't get that one. Now, let's look at 38. It says, determine whether the ordered pairs are solutions to the equation. And I'm going to work this out on paper. So I'm going to show you how we know this. All right, here's our equation. And first it says A is going to be 7 and 15. All right, so we're going to try. Remember, which is the X and which is the Y? Okay, first is the X, second is the Y, right? So now we're just going to take those numbers and we're going to stick them in there and see if it works. So Y, they say is 15, equals 2 times X, which they say is 7, minus 1. Okay, let's see what happens. 15 equals, what's 2 times 7? 14, minus 1. So 15 equals 14 minus 1 is 13. Is that true? No. So in that case, no. The answer to A was no. Let's look at B. Okay, so for B, we have -4, -9. And we're using that same formula. So we're going to come back and we're going to say, okay, this is our Y. So -9 equals 2 times -4. That's what they want X to be, minus 1. Okay, let's see what this becomes. -9 equals, what's 2 times -4? -8 minus 1. -9 equals, what's -8 minus 1? -9. So yes, so that one works. So our answer for this one is yes. Okay, let's look at 39. What does it give us for 39? It says Y is equal to -1/3 X plus 2. All right, and then it says for A, it says here's what you get. You get 1 5/3. Oh, fun. We love those fractions, don't we? All right, so let's see if this works. Y they think is 5/3. 5/3 equals -1/3 times, what do they say X is? 1 plus 2. All right, let's see what happens. Bring them down. 5/3 equals, what's -1/3 times 1? Well, you know what? Anything times 1 is going to be itself. So this is, again, -1/3 plus 2. Okay, now what am I going to have to do? Now I'm going to have to make it a fraction, or I'm going to have to make it a problem up and down, because I've got to put the negative 1/3 with the 2. So this is 2 minus 1/3. How do I do this? Do you guys remember? I borrow from the 2, it becomes a 1. I make it 3/3. Why do I make it 3/3? Because the denominator in my 1/3 is 3. Okay, so this ends up being 3/3 minus 1/3, 2/3, right? 3 minus 1 is 2, 1. Now, here's our only thing. They've given us an improper fraction over here. No problem. We know how to make a mixed number into an improper fraction. So what's 1 and 2/3? 3 times 1 is 3, plus 2 is 5. So guess what? 5/3 equals 5/3, and that one's a yes. A lot of work for one yes, though. I do agree. All right, last one. Let's work out B together. 0 and 6. All right, so y they think is 6 equals negative 1/3 times, what do they want x to be? 0. Well, that's nice and easy. Plus 2. All right, so 6 comes down. 6 equals, what's negative 1/3 times 0? Guess what? Anything times 0 is 0. 0 plus 2. So they're saying 6 is equal to 2. Well, I don't think so. So the answer to this one is a no. All right, guys, thank you for tuning in. And remember, you can email me, text me if you have any problems on what we're doing.